Hello and welcome to the DoneJS Contributors Meeting. Today is Friday, September 29th, 2017. My name is Chasen Lahara, coming to you from Long Beach, California. We've got a good, yeah, from the LBC. We've got a good gang today. Y'all want to introduce yourselves? Brad, do you want to start?
I didn't, but I guess I will.
Cool.
Hey everyone, Brad here, the Toby 4JS developer coming from Worcester, Massachusetts. And let's do a fun thing as well to get everybody started. Yeah, I'm drinking tea right now.
Tea is good. Tea is a good wake-up drink. Julian. Or sorry, Sheriff. You're muted. There you go.
Hi, I'm Sheriff from Algiers in Algeria. I'm in the open source team in DoneJS as a contributor.
Good to see you.
Thank you.
Yeah, my name is Julian. I'm from Germany, Stuttgart, and nice to be here.
Good to see you.
I'm Justin. I'm from Chicago, and I actually don't have a thing prepared, so give me a minute. I've been really working on my radio voice lately, doing recording for the streaming video.
Ooh, nice microphone that you got there.
I'm not using it right now, though.
Still looks cool. Hey, I'm Kevin. I'm not lying anymore, so I'm from Westmont, Illinois, not Chicago.
Oh, the truth comes out.
Yeah, and I'm drinking tea also.
Nice.
Hi, Matthew.
Sorry, Matthew.
I'm Matthew. I'm from Kentucky. See, interesting. I haven't eaten in like 16. I didn't have dinner last night or breakfast this morning, so I'm pretty hungry. Just kidding. I'm curious.
Hopefully you can get that resolved. All right, let's go and do statuses. So we'll talk about what we worked on this last week and then what we are going to work on the following week. Matthew, do you mind starting us off?
I do not mind. I've been working on DoneSSR zones, which I should probably drop a link somewhere. There's a link that has like the README, or excuse me, has like the list of zones. So you can use all of the SSR stuff that we do in DoneSSR. You can kind of do that yourself just using can zone itself. So basically took everything that's part of DoneSSR and broke it out. Mutations, loading steel, all the CanJS stuff. So just kind of, it's really a nice refactor of DoneSSR as well. So I'm finishing up, taking everything that I've done, creating all these new zones, putting it back in the DoneSSR itself. Almost finished with that. I just have really incremental renderings, the last thing I'm working on. And once that's done, I'll be working on a guide on how to use this incremental rendering with the React app. So yeah, that's what we're working on.
Sweet, sounds good. Kevin.
Yeah, this week I published a module called can simple observable, which is like 35 lines of code that you need to make a value observable with can reflect. The docs, it's interesting, the docs are actually longer than the code, which is good. Other than that, I fixed some issues with can reflect in IE 11, which was annoying, but is working now. And then I also added sauce lives to can reflect, and in doing that, I put together the steps of how to do that so that we can do that with other things. Next week, I'm going to be finishing up CanJS 3.11.0, hopefully get that released, and then moving on to CanStash 4.0, which I think we'll talk about later.
Cool, sounds good. Justin.
So this week I worked on can queues and can key tree. I think I showed can key tree last time, maybe, but I'll demo it today if I did not.
Cool, sounds good. Julian.
I worked on steel stuff, so I fixed an issue with steel and the optimized build. Now it can handle the bundle asset function in the Slim loader or in the optimized build. And I file some issues with the Slim loader or the optimized build. I created a progressive web app example for Steel. I can put it into the form. And yeah, that's all the stuff. There's service worker inside. There's runtime caching inside, manifest, web manifest inside, and Done auto render for the auto render stuff. But it's not for SSR. So the example is not server side rendered. Yeah, that's what I'm working on.
Sweet, sounds good. Sheriff.
Okay, so this week I worked on adding an Ajax module to the infrastructure documentation and fix some tests to make it work on the repository of CanJS website. And I worked on the issue on can/stash converters, issue number 22 for index to selected to handle for handling the case where there is no selection. So I added the test, and the test is working. There is a PR opened, but I mentioned the don't merge this PR because maybe we need to document how to handle the undefined selection on index to select it. And the next week, I will continue on fixing other issues on DoneJS and CanJS repositories. That's it for me.
Awesome, sounds good. Brad.
There we go. Having trouble unmuting. All right, so this week I've been working on a bunch of review and merging for updates related to CanJS 3.11. One thing I have been also doing is getting the deprecation of the set with an object in can-define list up to speed so that it saves the length property properly. So that length is always a number and you can iterate without worrying about it running forever. Also been working on a script to detect when any can package has a cycle in its dependencies. So if like package A depends on package B, which depends on package A, it'll catch that before you try to push it up to the source control. I've been sort of added in for a couple days, and I will probably be throwing it out and starting again to make something that's faster and you can use in every test cycle. And then from here on out I'll just be working on more on getting 3.11 out the door next week.
Cool, sounds good. This past week, I published an article called Introducing React View Model, MVVM with React. Check that out. Link is already in the forum post. Related to that, I released a patch update to React View Model that sets the peer dependency to also accept React 16. So that's published and out now. And then most of the other stuff I worked on was related to the community survey that we conducted this week. So let's actually, I guess next week I'll start working on grouping the API docs for CanJS by purpose instead of collection. Spoiler alert, that's the thing that I'll be tackling for our next product cycle. Let's get into the survey results. So I presume Kevin and Matthew, do you guys want to talk about how the results came out and how we'll be prioritizing our resources?
Yes, we would like to do that.
Cool.
All right. Let me try to see if I can find the survey results. Is there a public place for that?
I just linked to the gist that I created in our chat that has the
Oh, I see.
ranked.
Okay. Yeah. So I think the survey we're talking about the issues is what you're talking about, right?
Yeah, talking about the multiple choice answers that people indicated their interest in.
Okay. So I think for DoneJS, DoneJS it's hard to tell it's hard to glean anything from the results because you got 3 possible answers, or you got 3 choices, and there's only 4
Do you want to
possible
share your
answers.
screen so people can see?
Yeah,
Kevin,
I'm sharing mine. Yeah, Jason, if you want to select me.
Yeah, can we select Kevin's?
Yep, Kevin's presented.
Yeah, so as you can see, add an ecosystem generator plugin page. This is a page on DoneJS.com that shows different modules in the DoneJS ecosystem. That was number 1. PWA support was number 2. Updated terminal for DoneJS Develop was 3, and documentation on customizing the generator templates was 4th. However, the actual vote numbers were very close for all 4 of these, and again, I think it's because each person could choose up to 3, so there wasn't anything that was like very low.
Yeah, we'll definitely change that in the future when we only have such few options, not having people select so many.
Yeah, so I think like ecosystem generator plugin page was ranked 1st, but it only had like 1 more vote than PWA, so it's very close. So we'll be doing this again in the future. I don't think we're going to select any of the DoneJS issues for this product cycle. However, we will be selecting one from Steel. Kevin, if you don't mind scrolling down.
And one thing we should make clear is the next survey, right, might have different. Even though we're not doing anything for DoneJS, we'll have probably different options for DoneJS to maybe we'll take the top 2, PWA and ecosystem, and then maybe we'll propose 2 more or 3 more and just see how those compare. So we can, when we do a DoneJS issue, we're going to make sure we're doing the right.
Yeah, I'd want to take at least the top 3 because I think all of those were only like 1 vote apart from each other.
Yeah.
So is there how many people voted? Is there an indicator?
I know we know that number.
Jason, do you have a page that shows the actual numbers?
I don't have a public one, but I can post that.
Because I'm interested how many people voted, and just for.
Yeah.
There's like 50, maybe, something like that, Jason, right?
Yeah, so total respondents was 48 for the survey.
48 for the survey. Yeah.
Okay.
I was trying to find the other. Well, anyways, let me just go on. Yeah, still reorganizing the API page by topic. This is the issue where, let me share my screen. This is the issue where, kind of still JS's guide or API page is a little bit of a mess. We want to give some better organization by topics, like high-level topics like development bundles and hot module swapping, which is library load and that kind of thing, treat or code splitting. More of like, kind of the big issues, the kind of things that people actually come to Steel for is like, hey, I want to know how to use Babel, or I want to know, how to use bundle manifest. And I'm gonna update all the pages that we have that some of these topics we already have covered. I'm gonna update them to be more kind of generic about the topic, and then split off into like, step-by-step guide where necessary. We spent a lot of time on this. So this is the one we're going to select. Like I said, the other ones were pretty close to each other. Tree shaking was the second. Automatic removing of the main, Babel preset env, and then transpiling other formats other than ESM. Just being able to transpile common JS modules. But yeah, for this particular cycle, I'm gonna do this one. And that's the only one from Steel or DoneJS that we're gonna do.
Yeah. One sec, let me. All right. Sorry, I'm trying to pull the secret results. Just kidding. All right, I'll share my screen. Maybe. All right. So the results for CanJS were a little bit more surprising, I think, than we expected for some of the answers, and then for some of them, they're very much what we expected. The top two things were make CanJS easier to debug and group API docs by purpose instead of collection, and those two were pretty much a tie. And then the next two were queues for error-free and traceable code that Justin presented. Must have done a great job presenting because people love that, and that was a little bit, I think, unexpected. And then make it easier to configure and understand can set, which I know is a problem that a lot of people have. And then the next two were allow can observe to work without proxies and with plain objects and arrays. And then there was kind of a tie between these three. So can observe and then JSX and can stash 4.0. So I don't know if we want, I'm not going to go into detail on all of those, I don't think, because I think most of them people will remember from last week. But we can kind of talk about the things that we're planning to work on in this upcoming product cycle. I don't know if Justin, if you want to talk about that, or I can kind of mention them if you want.
You can talk about
it. Okay, cool. So yeah, I think we're going to try to tackle a lot of these. So we're going to probably try to tackle the top 5 or 6 of them. So we're going to work on making CanJS easier to debug. Jason's going to work on updating the API docs to be a little bit easier to find what you're looking for. Justin's working on his CanQ stuff, which is kind of already started. So making it easier to configure and understand can set. Do we decide what we're going to do with that?
Yeah, we don't know yet if we have a resource for that. That one's tricky because not many people have experience with can set enough to do that at Bitovi. It's kind of, there's a bottleneck with me in some ways there. And since I'm doing the queue stuff, if I can get done that real quick and then do the can set stuff, I will. Otherwise, if we can, maybe we might find someone at Bitovi who has time and just like can kind of work on it. We want to do that one because people voted for it, which was a surprise actually, but because so many people voted for it, we want to do it. We just need to find someone who can do it efficiently.
Yeah, if nothing else, we're definitely going to take the first steps to getting that accomplished. So making sure we understand what this means and documenting, breaking it up into issues and documenting those so someone can work on it eventually, if we don't have someone right now, I think. All right, and then the next one, allow can observe to work, to make plain objects and arrays observable and work without proxy. I don't know, kind of the same question. What do we want to do with that?
Well, I think what we can do is just, instead of doing that, we just buy into proxy wholesale. And just start working with proxy. So the idea is, so proxies have one downfall and a lot of other positives. The one problem, proxies don't allow you to, like, your source object will not be triple equal to the proxied object. But other than that, proxies allow us a lot of power and flexibility. Ideally, someone could get this can observe as long as you wrap your instance with a proxy, it'll make it observable. And then things like you could just have a class and make that a view model. And if you had wanted to set expanded prop on your view model, if that was 1, 2, 3, it would just work. So, I mean, it's I think it would it makes things a lot nicer, right? That you can just use classes and you can add properties to them like you would a normal object. You don't have to predefine them, and things just work.
Cool.
Yeah.
All right, and then after that, the next two, so JSX and CAN-STASH 4.0, were basically a tie. So they both got a lot of votes. There's obviously a lot of people want us to update our templating in different ways. So what we kind of decided is that since these were a tie, and since the effort needed to support JSX, and also like the unknowns with supporting JSX are much, much higher than CAN-STASH 4.0, we're going to go ahead with CAN-STASH 4.0. So that's kind of what I will be working on next week. And I've kind of broken this down into a dozen issues or whatever. So we'll be starting on that, and then we'll look to support JSX sometime in the future, since that's that is also something that a lot of people want. Cool. I think that's it.
I was surprised more people didn't want the JSX like template, but
yeah,
maybe hit that 6 weeks from now.
Yeah, I think that's actually worth repeating. We're talking about what people voted for, and this kind of sets our direction for our next 6 weeks. But we'll have a survey again, just because we're not picking up, or we're not able to immediately start working on issues that were highly voted now, doesn't mean that we're not going to be working on them in the future too.
Yeah, and if you really wanted to see JSX, make sure to call your congressperson, and we'll get that done.
Keep the phone lines tied. Cool. Does anyone have any questions or comments about the survey before we move on to other topics? Nope. Cool. Justin, I think you had a topic.
Yeah.
King Key Tree.
And one thing I forgot to mention is I did write a blog article on how basically it's about symbols and can reflect and why we're using them and how to make integration easier with different parts of CAN.js. I think it's a pretty good read, especially if you don't understand exactly what symbols are and how they could be useful, and the reflect API that's in JavaScript, and how I think it's for the most part pretty lame, but ours is much cooler. And just about reflection APIs in general. I don't know. Check it out. All right, yeah. So the topic I wanted to just go through is CAN key tree. This is something that, I don't know, Austin at Bitovi was having to build what did he make? Oh, he was making a memoizer type function. So like if you ever had a compute, it was kind of like making computes out of functions that would memoize functions, but like a function call, it would memoize it into a compute. And I realized this same pattern, something I've actually realized before, and made, I think, another utility like 6 years ago for, but it wasn't very good. And I was like, okay, I want to see if I can fix this problem, because it's everywhere inside CAN.js. So I made this CAN key tree that is a constructor function that essentially it creates trees that are, for the most part until the very end, it's like key value trees. So like the vertices of a tree would be some key value, and you can specify the type. So this would create a key tree if it's like object array. This means you could have this means the root of the tree would be an object, and if you wanted to store, well, let me show the example again. So if you call, oh, I actually show this, never mind. So let's say I wanted to store some handlers kind of organized by essentially the type of event and then maybe a CSS selector, I could call key tree add, and then like this. And what that's going to do is create a structure where the root of the tree is an object, because I said it's an object. And then this will be added as a property or a key on that object. And then the next level structure down is objects as well. They take these as keys. And then the final structure is an array, and those handlers get set in this array. So if you do something like this, you know, it will go and add those handlers in this nice tree pattern. It allows you to call get, which will get you all of the handlers. But if you want, it also allows you to ask for essentially the leaves at any node. So like if I wanted all click handlers, not just the click handlers for LI, I could just ask click, and that will essentially, you know, get the handlers in the LI and the span, which is really useful for a lot of things we want to do in CanJS. And there's a delete that works very similar, where you can delete a handler, but you could also delete all click handlers with this. And because they're all click handlers, one other thing it does is it recursively like prunes the data structure. So if you remove all click handlers, it's actually going to remove this click property. So the ending tree structure would be an empty object. So it also now has on first and on empty callbacks, which lets you know when like the tree has a single value and then when it no longer has the value. This is for, you know, lifecycle stuff, Kevin. Or if we want to do event handlers, like life cycles, you can provide callbacks there and know when essentially you have a handler. So to show some advanced usage, the real cool part about this that I think what's really useful is that these types don't have to be objects and arrays. They can be whatever you want. They just need to comply with can reflect. So I could do some cool event delegation stuff using that. And this example shows how to do that. So what I want to do is have like an event tree that I could say, hey, at this context, go listen on click for any LIs and call this handler. And I could remove the same handlers. This is like jQuery like event delegation. I want to build a tree that does that. Well, the secret to this is I'm going to build a tree of ES maps to a delegator type that I'm going to create that is an object and an array, right? So essentially the map is the key tree is going to store every object, the root of what we're delegating. Then it's going to store essentially like essentially an event binding for a given event for click, an event binding for a click essentially. And then it's going to store all the CSS selectors and then all of the handlers that need to be dispatched for that CSS selector. So, you know, I can use it the same way, right? Pretty powerful stuff. And then the implementation is relatively simple of my delegator type. I have to implement a constructor function, and it needs to set key value, get key value, and delete key value and own enumerable key value. So it's basically just like a map I'm implementing, but it can do special things whenever a new value is set in the map. So for instance, when you set up a click, it's going to try to set, so when I do this click, what it's going to try to do is create a new delegator where click points to essentially an object of selectors with their handlers. So that's this event name. A click is going to be set with an object of event selectors to their handlers. I can store, you know, my own data structure. I store things in this delegated, and I also store things in this events. I'm going to create a function to call back that I'm going to bind on click. So this is basically so I can clean myself up. I'm storing my delegated event handler. And this is going to do event delegation. It's going to go through every selector, see if the target matches it. And if it does, call the handlers for that selector. Right? Real basic event delegation. And I'm also storing my handlers by selector for that event, right? So I'm just storing the function that we created and also just kind of the handlers that I need to map down. Get key value, well, that just returns the handlers by selector, the data structure that is next. Delete is going to remove the event binding and remove that that data, right? That event, so we're no longer listing on click anymore. I'm going to remove that, and then I just need to tell the number of keys, so I can just essentially the number of things remaining on events is the number of keys on this object. So just with this, right? I'm just implementing a tree. Oh, and the constructor gets called with its parent key, so like it gets essentially called with the element that the map points to this delegator. So it's, you know, the LI or whatever, the document body. So I have the document body. I keep that so that I can essentially do bindings on it. And that's it. With just this amount of code, I've implemented event delegation just like what jQuery supports. It's not quite as fast as what jQuery supports because of the way I'm looping here. I could fix that, but all of that ability to, like, you know, remove, you know, all things by selector, or, you know, remove an individual handler, or remove everything listening on document body, I can do that now. So this is a pretty useful tool, I think, now in CanJS's arsenal. I think what's going to happen while I'm doing CanQs is I'm going to change all of the event system stuff to use this under the hood. Now, I expect that means our bindings will get slightly slower, but my hope is not too much slower, and then I will kind of do some further performance tuning on tree to make it fast. So that's CanKey tree. Any questions?
How do you go through the tree to find a key?
You can say get, and then you provided the key.
Yeah, but how is it implemented? How is it working? How do you find? Is there a loop through all the keys, or is that?
Yeah, there's a loop, but it goes. So what happens is if you do get click, it's just going to do on the root. It's just going to read the click property on the root, and then it is going to traverse the remainder of essentially it's going to, you know, very quickly just do root.click, get to this, and then it's going to have to traverse the remainder of the tree to find all of the handlers. So what it's really just doing is here, get key. It's just saying get own enumerable keys, gets li and span, and then goes to the li, says give me all your values, and then as the span, give me all your values, adds those together into like one big array and returns it. And that's
what's if you get click li, and maybe you go down further, you have more.
Then this is really fast. I mean, this is really fast because then it's literally just there's just a loop that just does, you know, get the start at root, and then your new root is this object, then read the li property.
Yeah, but if you have if you have click ul li, for example, and you have another object, so you have to go through the object of of click, find the ul element, and then the li.
Yeah, I mean, it can be as deep as your tree can go. I mean,
but is it slower? Is it slower if the tree gets deeper?
I mean, yeah, of course, but not slower than. I mean, algorithmically, it's no different than what we're doing currently. Right, what we're doing currently in CanJS for this kind of stuff is like we have our this.bind events, right, which is really our root. And there's code that, like, if you wanted to remove a particular event handler like this, what it's going to do is say, like, well, it's going to first be like, you know, var handlers for type, and then it's going to do this.bind events well, because this is always keyed anyways, it's going to be like event name. And then it's going to do like if, as long as there is handlers by type, if there's that, then it's going to go handlers for selector. Handlers by type, selector. And then if handlers for selector, you know, then it's going to return, well, in this case, it's going to return that, right? The logic, I mean, if this tree kept getting deeper and deeper and deeper, you would have to still keep having this if, right? You can imagine like now it's handlers for selector, but then it's like there's some other qualification, ABC, so you would do the same thing. If handlers for selector, the next thing that you would look down would be like this, and you would just keep having the same pattern of checking if the value's there, and then you know, checking if the value's there, and then getting the next key down, and you still have a loop, right? It's just hard coded instead of like a while loop, which I'm using inside get, but the amount of operations is still the same. Well, algorithmically the same.
But is this maybe not a better option for example, you have a click and you have an inside you have an object and you have an UL, and inside that you have the LI element. So you have cascading that one more deeper. Is it not better to have if you have only one LI element in your UL element, you can shrink them together in one? Do you know what I mean?
I'm not sure what you mean.
That measurement.
You're saying I have like a UL in here, right? Too.
Yeah,
right?
and
okay.
Yeah, so and only one element. So you can have LI space UL because it's not
what
in the click. You have LI and then make a space and write UL.
Oh well, that's how it would be. I mean, this event delegation, that's how it works. Like you would to be clear, we're not keeping that in a tree. You do like LI UL like that, and the tree structure for this is like for the event delegation example, the tree structure is still gonna have it's gonna look like this. There's essentially a map, right, where the key would be document.body to a delegator type, which essentially is going to have a click mapped to a LI UL to a list of handlers. That's the data structure that gets stored, right? Each selector is a key. It's not like there's nothing that's breaking this up and then like making deeper tree structures. This is the key.
Okay.
Does that make sense? Was that what you were thinking? That this was like somehow being split and?
Yeah, I thought it's gonna split and then the tree get deeper.
No, there's nothing that does that. This is the key, right? So like if I did LI space UL, that's just the key, right? And the tree depth is still only 1, 2, 3, 4 items deep. It'll only be 4 items deep. It can't ever get deeper. This tree does not allow depths of varying lengths. It always has to be for values, the end values, it always has to be like 4 items deep or whatever whenever you declare your type.
Okay.
That's what it has to be, right? So it's got to be object array. It can't like have like 15 objects and then your final value. It doesn't work like that. So anyways, I wanted to show this, especially because, you know, well, in some ways my audience is Kevin and other people who are in the weeds of CanJS. This is a very useful, I think extremely useful utility now. There's just so many, like, not only our event delegation, this can simplify, there's that mutation observers thing, that whole DOM data, actually, one thing I did, but I didn't document it here, is you can actually, the root doesn't have to be, you can provide an instance of a object type for the root. So I made it so that if like DOM data, for instance, was can reflected appropriately, you could just use like DOM data as, you know, if that had the right like add key value, remove key value, those kind of methods on it, then you could just stick that there, and you would have a tree that you could store things in DOM data. So that whole what's it called? The mutation stuff could use this.
Awesome.
Yeah. I also, there's a tweet that I had, which I was like lazy web, like, hey, what do you call something that can like store things like in a tree structure? And then I was like, oh yeah, it's called a tree. I was trying to come up with the name for this pattern. I was like, oh yeah, it's just a tree. So that's it for me. Hopefully people find this useful.
Sweet. I think that was all of the topics that were posted in the forums. Did anyone have anything else before we go? Nope. Cool. All right. Everyone who's watching the YouTube live stream, thanks for watching, or on YouTube afterwards. And see you guys in a week. Bye.